Okay, optimization in 2.7. What we're talking about in this section is going to be about finding maximums and minimums. We kind of have two different types of these. We can call one type local or relative. All right, different books use different terminology on this, but this doesn't have to be the very highest or the very lowest point on the entire graph. So we say f has a local maximum at some number a if f of a is greater than or equal to f of x for all those x's that are anywhere near a. Or vice versa if we're thinking about minimums. All right, so let's take a look at what these would look like in practice when we're looking at a graph. So it could be a point that's at the left end point. It could be the top of a hill would be a maximum. It could be the top of a mountain, something like that would be a maximum. It could be the top of a cusp. Or it could be a right end point, something like that if the graph stops on the right hand side. If you want to think about, right, these were maximums. If you want to think about minimums, you can flip all these upside down. And basically those are pretty much all the different shapes you're going to be able to have. Okay, when we put the maximums and minimums together, we call these all local extremes or local extrema. What we're trying to do in this section is, one, look at them on graphs, see what they look like, but also try to find these maximums and minimums. We call that process optimization. All right, the next type is global maximums and minimums. Global maximum or absolute maximum is just the very, very highest point on the entire graph. Minimum's the opposite, right? The lowest point on the entire graph would be absolute or global. Those are interchangeable words. So let's take a look at a quick graph here. As you can see, these are labeled. This is a minimum. It's not the very lowest point on the entire graph, but in this short all the points around it, like the short interval, looking right here, it is the lowest point. The global maximum, right here, it's also going to be a local maximum. All right, that's one thing that I like to think about. Like if you were the very, very best basketball player in the entire world, if you happen to be in a particular city, then you would be the very best in that city also. So you would be both globally the very best, the maximum, and locally the maximum. All right, a local minimum, local maximum because it's not the highest point on the entire graph, and then this one at the bottom gets classified as both global and local minimum. All right, you may be asking about those endpoints. We don't know exactly what happens on this graph, but it looks to me like they stop. So on the ends, we could also classify these as that would be a local maximum because it's bigger up higher on the graph than all the points around it. And on the right end point, that also could be a local maximum. All right, hope this helps out as you're trying to visualize what global and local maximums look like.